Bismillahirrahmanirrahim. So, as I remember in the last class, we were discussing about the types of motion, okay? And the last type of motion that we discussed was periodic motion, right?
Yes.
Okay.
Yes, sir.
I want one of you to explain me what is periodic motion. Eva, can you? There are 2 points that I wrote, that these 2 points must be there in the definition in order to get full mark. What are those 2 points for periodic motion?
Um, starts.
I want to know from Eva.
Okay.
Eva, can you answer? Okay.
No,
Someone else? Fatima Akhtar Munni.
Yes,
Okay.
sir.
You were not there in the last class, right? But did you take note?
Yeah. Yes, sir.
So can you tell me that what are the 2 points that I said in the last class that must be there in the definition of periodic motion to get full marks?
Mm. What?
Sumaya,
Sir, I forgot.
Sir, that is like it has to travel at the same direction or same distance, we can say.
nobody took note. If you have taken note, it should be there in your notebook, right? You can see and you can say.
From
Across
same
a certain
direction,
point
definite
from
interval
same
of time.
direction.
Time interval.
There were 2 points, okay? A particle
Yes, sir.
will cross a point on its path from the same direction,
Yes.
and it will cross after a definite time interval. That means, let us say if it crossed now and after 5 seconds again it crossed, then again after 5 seconds exactly it will cross. It will never happen that it crossed after 5 seconds, then the next time it crossed after 6 seconds. It took a little bit longer time. No, that is not periodic motion. Time period has to be same. Okay, that's why we take the example of hand of a clock, because it always does the same. Okay, the second hand of a clock, it will cross a certain point just after 60 seconds exactly. It will never happen that the next time it will cross the point after 59 seconds or 61 seconds, right? And if
Yes.
it is about the minute hand of a clock, it will cross the exact same point after 60 minutes, or 1 hour, we can say. And then the hour hand of a clock, that will cover the same point after how many?
60.
60 seconds.
The hour hand of a clock, it will cross the same point after how many hours?
12.
12. 12.
Hours. Okay, not 24 hours. Many people make this mistake. They think that the hour hand will complete a round.
No,
And
sir, it's coming two time, 12 and 12.
Yes, 12.
right. So if it is 12 o'clock now, after 12 hours, it will come back to 12 again, right? So the time period
Yes.
of hour hand of a clock is 12 hours. Very good. Okay. So now the next topic that we want to discuss is vibratory motion. Okay, we all know about this vibrator, right? Let us say the
Yes.
bottom part is fixed of this one, and I hit it with something like for a yellow. Normally, if the bottom part is rigidly fixed and if I hit it, what is supposed to happen? This will start vibrating, right? If I hit it
Yes.
with something, then it will start vibrating. So this is vibratory motion. But in order to write the definition, what are the points that need to be there? Okay, number 1 point, vibratory motion is also like periodic motion. There is only a slight difference. What is the difference? Okay. So vibratory motion, it will cross the same point repeatedly, okay, from the opposite direction. This is the difference. In case of periodic motion, it was from the same direction, but in case of vibratory motion, it will be the opposite direction. Why? I will explain. And also after definite time interval. So the example of this type of motion, okay, I can say a simple pendulum. Simple pendulum. Okay, there are some pendulum clocks actually. If you have seen, I don't know whether it is available in Bahrain or not, but in my childhood, in many of the houses, I used to see this wall clock.
Yes, sir, it's too big. I saw.
It's very big, and below the dial, okay, actually they are used to hang a thing like this, and it used to oscillate like this. It will go from here to here, and then from here it will come back again. So it will keep doing like this. Okay. So
Yeah.
a simple pendulum, it is one of the best example of vibratory motion. And it is also called, actually there are certain several names of this one. It is also called oscillatory motion. Oscillatory motion, and it is also known as simple harmonic motion. Simple harmonic motion. Now, sometimes simple harmonic motion, this is written in short as SHM. So in the question, if you ever see SHM, do not get confused. It is referring to simple harmonic motion or oscillatory motion or vibratory motion. Okay. So now let us consider any point on its path. Okay. Let us say we are considering this point. Okay. You will see that when it will start vibrating, what will happen? It will cross this point from this direction, and when it will come here and then it will start going back, it will cross the same point now from the opposite direction. Correct? So in every oscillation, it will cross the same point from one first time it will cross from one direction, and the next time it will cross from the opposite direction. So that is what it means, crosses the same point repeatedly, means again and again, okay, from the opposite direction, once from this direction, another one from the opposite direction. So as I was saying, this is also a vibratory motion. So can you notice, if I put a finger here, let us say this is a point, you see that this finger point, it is crossing from this direction. From this direction it crossed, and then when it will come back, it will cross the same point from the opposite direction, right? Easy to understand.
Yes.
Did you get the point?
Yes.
Yes,
Yes.
sir.
The time interval needs to be same, as I already said. Okay, so let us say now it crossed. Okay, maybe the time is 0, we started counting, and we saw that it came back to this point after 2 seconds, and then again after 2 seconds it will come back here. So that way we can say that the time interval will be definite. Okay, that means if the body is here now, from here what will happen, this body will go here and then again come back. Let us say it took 2 seconds, then again this body went here and come back again. It has to take 2 seconds, and then again it will go here and come back. It will take again 2 seconds. That means after 2 seconds, after every 2 seconds, the body is coming back to this position. Okay, so this is called the time interval, and it is definite, fixed. It cannot take 2 seconds for the first time and 3 seconds for the second time and maybe 1 second for the next time. No, if it is changing, then we cannot say this is a proper vibratory motion. Okay, so for vibratory oscillatory or simple harmonic motion, what will happen? Crosses the same point repeatedly from opposite direction, and it has to be repeated after a definite time interval. The time interval is fixed. Okay. Anybody
Okay,
want
sir.
to ask any question?
No, sir.
Okay. So the definition is written in the book. Kindly go through.
Sir, how it's going in opposite?
Yeah. Half of the time it will go in one direction, and another half of the time it will go in another direction. Actually, there is another definition of this one. Should I write on the board? I think better if I explain that too. Okay. So let me write.
Yes, sir.
Okay, before I take you through the definition, okay, I want to explain what we mean by one oscillation. When I can say that one oscillation or one vibration has been completed. Okay. Let us say this pendulum has started vibrating from here. So when it will go to that extreme position and come back from where it started, then we can say it has completed one oscillation. And then what will happen? It will again go to that extreme position and again come back. We can say now two oscillation has been completed. Again it will go and come back. Three oscillation has been completed. Understood what I mean by oscillation?
Yes, sir.
So
Yes.
one oscillation, it has to come back to its original position from where it started. So if this one is one oscillation, then only going to that side, I can say this is half oscillation.
Yes.
Going from here to here, half oscillation completed, and when it came back again to this position, another half oscillation completed. Half plus
Yes.
half combined one completed, right? So
Yes.
here, half of the oscillation it was traveling in one direction, and another half of the oscillation it was traveling in the opposite direction, right? This is what
Yes.
is the characteristic of the vibratory motion. Okay, if the motion of a particle is such that, okay, half of the time of its oscillation, it goes in one direction, it will go in one direction, and another half in the opposite direction, another half of the oscillation it will go in the opposite direction. Then this motion can be called simple harmonic motion or vibratory motion or oscillatory motion. Is it clear?
Yes, sir.
Okay. Okay, then inshallah we will move to the next topic, that is a scalar and vector quantity. Okay. So as I was saying, writing only the answer is not enough. Okay, the presentation is important because everyone will be writing the same definition. Let us say you have been asked to write the definition of a vibratory motion. So for 1 mark, it is enough if you write the definition. But the people who will provide a figure of simple pendulum and write the example as that the example of vibratory motion is simple harmonic motion. Sorry, simple pendulum. Okay. So someone who will provide something extra, will the teacher give him 2 out of 1?
No.
No.
1 mark, you will get a 1 mark. Then why you should write more? Why I'm encouraging you to write a little bit more?
Why?
Nobody knows or nobody can guess?
For 2 marks, we can do that right, sir.
Huh?
I mean, bigger question, we can do that right, that example.
Sorry, I didn't get you.
I said that for B, I mean, in creative, in B, we can do that. Like, we can show that example.
Only. Generally, the definition defines something. This type of question you will see in A. That is for 1 mark. Okay. So if you write
Yes.
the definition, that is enough to get 1 mark. But still, I encourage the students to get, to write, a little bit more. If possible, they can provide a figure and an example, which actually doesn't take more than 30 seconds to provide, right? So it is not actually a waste of time. So why you need to write it? The thing is, when I was a student myself, I used to keep myself in the position of an examiner and used to think that how can I impress the examiner? How I would be impressed if I was the examiner myself. Okay. So just think about this way. You are checking 100 of paper. Everyone has same definition, same definition, same definition. But suddenly your paper appears and you have written not only just the definition, you have provided a figure and you have provided an example. What would be my impression with you? That you are a good student or you are a bad student?
Good student.
Definitely you are a good student. You know what is the effect of this impression? This is priceless. Because if at the beginning of the paper, if I get an impression that you are not a very good student, then you know what will happen? When later I will be checking your paper and I will see that you have solved a problem and you got the correct answer, I will still be doubtful that how did you get the correct answer, because you are not a good student. That is in my mind. right?
Yes.
Subconscious. It's not something, done intentionally. Okay, it comes in my mind that okay, let us say, do you know that in SSC exam, your paper will be checked by a person who doesn't know you. In Bangladesh,
Yeah.
who is going to check your
Yes.
paper? So in school, what happens? While I'm checking your paper, I know you because you are my student. I have seen you. But what about in SSC exam? The person who is checking the paper doesn't know you. He will know you through your paper. Whatever you will show him in your paper, according to that, he will get an idea about you. So at the beginning, if you can create a good impression that you are something different from others, you know what will happen? In the later question, even though you did not write something properly, still you will get good mark. He will be tending towards giving you, good mark, where other students will get for the same answer 2, but you might get 3 out of 4. Do you understand? This is the importance of uh, creating a good impression at the beginning of the paper. That is why we always encourage that start writing the answer with the answer that you know the best. Let us say there are 8 questions and 5 you have to write. So out of them, one creative is there which is you know best. You know A B C D all properly. So write that first. If you can impress the examiner with that first, then what will happen? In the rest of the answers, he will not check properly. That is the nature of a human being. You can imagine this, keeping yourself in the position of an examiner, right? When you have the pressure of taking hundreds of paper, what you do? You just try to get an idea about the student at the beginning of the paper, and then depending on that you will put mark. Okay, if I get an idea that you are a good student, and then in the next question I see that you have solved a difficult problem, I will say this is normal. My subconscious mind will tell me that this is normal, she's a good student, so answer is correct. That means all the above procedure that she has written is correct. I will not check thoroughly. But what if I get an idea that you are not a very good student and still you solve a difficult problem? Then I will be checking each and every line. Did she write the unit correct? Did she use the correct equation? Did she put the value in the proper place? And I will be looking for mistakes, right? And if I get
Yeah.
one mistake, I will deduct your mark. So
Yes.
you understand yourself, right? So
Yes.
Yes, sir. Get it.
whatever answer you write, okay, in home definitely you will practice. While practicing, ask yourself, okay, like this answer everyone will write in this way, how can I write it in a bit different way? Okay, so only knowledge is not enough to get a plus. Okay, sometimes being different is important, so try to be different. I When I was a student myself, I found out so many ways to be different from others. You have to do it yourself. Maybe I can share my techniques with you, but that's not now. Okay, inshallah, I will show you later. Uh, but you also have to come up with something. Okay, inshallah. So let us talk about this scalar and vector quantity. At first, let us say quantities. Okay, very important topic of physics. Which are the things that we can say quantity? Anything that can be measured, you can measure it. Let us say this marker. If I tell you measure the length of it, you can measure it using the scale, right? You will be able to tell me a value like 5 centimeter, 4 centimeter. You will be able to measure it, correct or not?
Yes,
Yes.
sir.
So this length is actually a quantity that can be measured. Okay. Now you will ask me, sir, then which one is not quantity? Everything can be measured. Everything cannot be measured. Let us say I tell you that I'm very happy today. So you ask me, sir, how much happy you are? Will I be able to tell you that I am 5 kg happy? Or I will,
No.
No,
No, sir.
will
No.
no,
I
No,
will
sir.
give you a value that okay, I am 100 happy, I am 200 sad, I am 1000
No.
angry.
No.
It's not measurable, right? So that is
Yes.
Yes.
not a quantity. That is human feelings. Okay, feeling happy, feeling sad, these things cannot be measured. So these are not actually quantity. Okay, I can tell you that I'm feeling a lot happy. Okay, but I will not be able to give you a particular value. So whatever that can be measured in case of numeric, that is number, okay, that are called quantity. Now such quantities are divided into two categories, that is a scalar quantity and the vector quantity. Okay, now scalar quantity, through example I will explain. The scalar quantity, only the magnitude is enough to express it. Okay, so if I ask you what is the length of this marker, you will only tell me 5 centimeter. Okay, I will write 5 centimeter. You know, this is called magnitude. Okay, magnitude, length or magnitude 5 centimeter. This much is enough. Is there any question that arises that in which direction? Is there any question that comes to your mind that, sir, did you measure it from this direction to that direction or this direction to that direction? Such question is unnecessary, right? Because it doesn't matter whether you measured it from here to here, it will be 5 centimeter, or you measure from this point to that point, it will be 5 centimeter. So direction is not needed, correct?
Yes.
Yes.
Now, it will be more clear if I explain the vector quantity also. Okay, then you will understand then direction, when the direction is needed. Okay, let us see. Vector quantity, this quantity, if you want to express it, only the magnitude is not enough. You have to mention the direction also. Let us say the example that I have written is velocity. Okay, so if I say the body is in velocity 5 meter per second. Okay, this is the speed of the body. But then the question arises, velocity means it is moving, right? But the question arises, in which direction it is moving? Is it moving in this direction? Or is it moving in this direction? Or up or down direction? In which direction it is moving? See, there is a question of direction, correct or not?
Yes.
Okay,
Yes.
so for such quantity, they will be named as vector quantity. When the magnitude 5 meter per second, see, this is magnitude, but this magnitude is not enough. You have to show the direction also. So I will put an arrow here. Now it is complete information that the body is in motion with 5 meter per second velocity, and it is moving in which direction? In this direction. Okay, so magnitude and direction both are important. Okay, so that is why it is called vector quantity. Now I want you to come up with some other example. I have written only one. Okay, intentionally I wrote only one because I want you to think of some other example. Can you think of some other quantity to express which we do not actually need to know the direction?
Kg of any body.
Hmm?
Kg of any body, kilogram.
Mass, right? Okay, there is
Yes.
actually a misconception. Whenever we say that my weight is 65 kg, it is not actually my weight, it is actually my mass. Okay, inshallah later about it you will get to know. Okay, বাংলাতে এটাকে বলে ভর। ওকে, মাস এর বাংলা হচ্ছে ভর। আমাদের ভর হচ্ছে 65 কেজি or 70 কেজি এরকম। ওয়েট যেটা সেটাকে আমরা ওজন বলি। তো ওজনটা কিভাবে মেশার করে এটা তোমরা অলরেডি শিখে আসছো যে W is equal to mg, মাস ইনটু অ্যাক্সিলারেশন ডিউ টু গ্র্যাভিটি। যখন করবা তখন তুমি ওয়েট পাবা। তো আমরা নরমালি যেটা মেজার করি এটা আমাদের ওজন না, এটা আমাদের ভর। ইংলিশে যদি বলে ইট ইজ নট আওয়ার ওয়েট, দ্যাট ইজ আওয়ার মাস। ওকে, আচ্ছা যাক, তো যেটা তুমি বলছো কারেক্ট, মাস ইজ আ কোয়ান্টিটি দ্যাট doesn't require any direction. Very good. কি আনসার দিছে এটা?
Sir, energy.
Marwa.
Marwa, very good. Energy, very good. Energy is another quantity that is that can be expressed by magnitude only. Direction is not important. Anyone else? Very good.
Spread. Spread.
Speed. Yes, speed actually, I don't know how you gave that answer, but uh,
I think it's come under a vector speed.
yes, speed and velocity, they are almost the same thing. Where is the difference? I will explain later, inshallah. Okay, not in today's class, we don't have enough time. I just want you to get a clear idea about these quantities. Okay, any other example which is commonly known?
Time.
Time.
Very good.
Oh.
So if I tell you that for how many hours you are studying, you will tell me 2 hours, 3 hours. Will you tell me that 2 hours in the up direction? 2 hour?
No.
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 Not required. You will tell me only the value, the magnitude that I have been studying for 2 hours. So time. Any other example? Temperature, right?
Humidity.
If I ask you what is the
Oh yeah.
you will tell me, sir, 24 degrees Celsius, 15 degrees Celsius. You will give me a value. You will never tell me, sir, 24 degrees Celsius in the downward direction. No?
No.
So that is why these are called scalar quantity. Okay. Now let us see a couple of examples of vector quantity. Okay. Uh, also, one more example I would like to mention over here in a scalar quantity, that is distance. If I ask you what is the distance between Muharrak and hill, you will be able to tell me a distance, right? That it is 5 kilometer, 10 kilometer. Direction is not required.
Yes.
Okay, either you measure it
Yes.
from Muharrak to hip or hip to Muharrak. Anyway, the value is going to be same. So distance is scalar quantity. But similar, a quantity is there, that is displacement. This is a vector
So
quantity.
it will come under
Hmm?
this display. This displacement will come under a vector, right?
Quantity. Why it is a vector quantity? Oh, there is less than 1 minute. Okay, think about it. Okay, displacement. Why this is a vector quantity? Look for this answer in your textbook. At the beginning of next class, inshallah, I will ask you that what is why displacement is vector quantity. I will see if you can answer. If anybody can answer, I will note it down, and he or she will get some extra mark in internal evaluation. Okay, in class.
Does acceleration fall on vector quantity?
Acceleration, but how do you know about acceleration?
Yeah,
Sir, I guess
because
because
I was
acceleration,
also
yeah,
thinking.
it's like a part of